everyone. Myself Vidyut Lata Sahu, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I'm going to discuss about the critical thinking question discussion on local search and non-deterministic actions. Actually, these two terms are related to our module 1 on the course Applied Artificial Intelligence. So, thought to discuss one or two questions. The critical thinking questions will not solve just how to think about the question. That is very important. So this is the course outcome. So after the completion of this course, students can discuss the appropriate search strategies and knowledge representation techniques to implement inference mechanisms for AI-based problem solving. Now, this is the question. The first question is, it looks like a very big question. Actually, it is a theoretical question, but it is a combination of different parts of the question. Now, how, if the question is given to a student, how a student can analyze and a student can give the answer. Our student can represent the answer on the paper. So here we are not testing that how the problem exactly 100% it will be solved. We are testing what would be the students' like critical thinking capability. So that is why I want to discuss about one or two critical thinking question on local search as well as non-deterministic actions. So the question says that you are working on an engineering project to design the optimal shape of a wing for an aircraft, aiming to minimize the drag while maintaining a structural integrity. The design space is continuous and there are many possible configurations to test. Now, plan how you would apply local search algorithm to find the optimal wing shape and describe the specific steps involved, how you would handle any constraints and how you would decide when to stop the search process. So few questions are there. So I will tell you what is the problem statement, what problem statement says, and what we have to plan here. Planning is, and you have to plan how we can apply local search algorithm to find the optimal wing shape and how you can handle the constraint, any constraint, and what would be the stopping criteria. So based for this part, we have to focus on it and we have to analyze the problem. Now, what exactly the problem says here? The problem statement says that we are designing an aircraft wing, okay, to minimize the drag while maintaining the structural integrity, and the wing shape can vary continuously. Wing shape means it may be the curvature or it may be the thickness of the wing or the angular movement of the wing. The shape of the wing we have to consider here. This is very important. And the design space is continuous and high dimensional. I know you might be facing problem because of the question related to the aircraft, related to the plane. So different aerodynamics or aeroplane terminologies are used, like wings and the drag. So all these terminologies. So it is very simple actually. Here we are designing the aircraft wing to minimize the drag while maintaining the structural integrity, and the wing shape can vary continuously, maybe from curvature to thickness and or in any angular action, and the design space is continuous and high dimensional. Okay. Space is continuous and it is a high dimensional space. It may be more than 3D space or 4D space or 5D space. That is why it is called as high dimensional. And so how to solve this particular problem? We are not solving exactly, just we are thinking, we are analyzing what are the steps we need to follow so that we can solve this problem. So what are the steps to apply the local search strategy? That is what in your problem statement says that here plan how you would apply local search strategy to find the optimal wing shape. So for that, we have to plan first what would be the steps are required. So to apply as I have already discussed when I discussed the local search algorithms, a local search or the search techniques is not like uniformed or uninformed search, informed or uninformed search. They are local to the point or to the location where we can use the gradient descent method, means using slope or without slope also. If it is using slope, then gradient descent method we can use. If it is without slope, then we can go for some other techniques like hill climbing or simulated annealing. So to apply the local search strategy to solve this problem, first of all, we have to define the objective function. And second step is we have to initialize the solution with some value. Then we'll define the local moves. Then constraint we will handle. Then we will find out what would be the acceptance criteria and what would be the stopping criteria. Here, what is the meaning of the objective function? This is related to the local search strategy, especially the objective function. It is a type of function which defines how whether the solution is good or bad at that particular moment of time. If it is good, then it is accepted. If it is bad, then it has to search for the neighboring solutions. That is why that is called as the objective function here. So defining the objective function is very important. So first step is we have to define the objective function. Now come to step 1, define the objective function. And one more thing, this objective function, the name is common in all the local search techniques, but the objective function, its configuration or the statement would vary from different situation to situation. So as the domain is related to spacecraft or aircraft, so that is why here the objective function we have to use using those terminologies like drag or penalty. So as like in mathematics, normally we used to use y is equal to mx plus c, where where m is the slope and c is the intercept. C is the y-intercept, right? So same thing here, we model the goal as a cost function to minimize the cost. So the objective function is nothing but the using which we can minimize the cost. So here cost of x we are assigning cost of x is equal to drag of x plus lambda into penalty of x, similar to our this mathematical equation for linear regression. So here the value x means it is a vector representing the design parameter, maybe the camber or cut length or strip angle. And here the drag means it estimated using the CFD simulations or surrogate models, and penalty which is added if structural or aerodynamics constraints are violated, and lambda. So lambda is nothing but the penalty weight to balance the trade-offs. Okay, like how here our slope is used, similarly here lambda we are using, which balances the weight. It is like a penalty weight we can say. So this is the way first we have to define the objective function. After that, the second step is initialize the solution. So after defining the objective function, we have to initialize some solution, means starts with a feasible wing shape, because all the local search, as per the concept of local search, you starts with any random solution. Already I have discussed when I discussed this topic, I think in my first video or second video. Local search technique starts with any random solution at any moment of time. Same thing, same concept is also applicable here to solve this problem. Start a feasible wing shape, which is called as the baseline design. Ensure it satisfies all the structural aerodynamics constraint. So whenever we are starting with any solution, so it should satisfy the structure of the aerodynamics or the wings and the shape of the wings, and that is why it is given as given that ensure it satisfies all the structural and aerodynamics constraints. After initializing the solution, then the third step is we have to define the local moves. Okay, define how to define the local moves means that in your local search, as we are finding at any point or like any solution as the random solution, and that would be the initial solution, then how we can suppose the solution, how we can find the solution based on the objective function, right? So based on the objective function depending upon the domain. Now, if the objective function says that at this particular moment of time or at this particular moment the solution is not a good solution, then what the agent tries to do? The agent tries to find out the next good possible solution or best possible solution by observing its neighbors, either gradient descent or gradient ascent. So ascent means increasing, gradient descent means decreasing. So wherever it finds the good solution, there the current point will be moved to that point. Now the current point is this one, for example, right? So here how theoretically we are saying that the solution will be moved to the next location or the neighboring solution if it is a good solution. Now this neighboring solution is a good solution or not, that can be defined by changing the value of m, or here by changing the value of x. So here the small parameter, the small value of x, which is called as x dash, will be changed by adding some parameter or small vector, that is delta. So x dash is equal to x plus delta, where delta is a small vector of random changes, normally or uniformly distributed. So small change in the step size. Already I have discussed what is the meaning of step size. So from one location to second location, it changes. From second location to third location, it changes. From third location to fourth location, and changes until a good solution is found. Suppose at this point the good solution is found, then this solution is considered as the best solution. But how the step size is changed, that depends upon this x dash value. So here it only accepts the feasible changes, obey the constraint or apply the penalties. Then the fourth step is constraint handling. So you can handle the constraints in various ways. Here we can handle the constraint in three ways, either using the penalty method, or using the repair method, or using the reject method. So penalty method means add a large cost if the constraints are violated. Repair method says that automatically adjust the infeasible solutions back into the feasible region. And reject method says discard the infeasible moves if it is less preferred or reduces the exploration. So these are the methods which we used to use in local search technique to handle the constraint. Then the fifth step is we have to check what would be the acceptance criteria. When we can say that the solution is a good solution, if the cost of x dash is less than cost of x, accept the new design. That means here cost of x dash is less than cost of x. So it follows gradient descent method. That means suppose at the random we are getting this random solution, we have initialized at x, then if we follow this gradient descent method, so it may be the x dash. If this value decreases, means cost of x dash is less than cost of x, then it is considered as a good solution here. So as per this formula, as per this condition, gradient descent is used. Suppose I would have written like cost of x dash is more than cost of x. That means in that case we will follow gradient ascent. Gradient ascent. But in this case we are following gradient descent. It is moving backward direction. So if this condition is satisfied, then we can say accept the new design. So optional is use simulated annealing to occasionally accept worse designs and escape local minima. So already you know what is this simulated annealing. That concept can also be used instead of this gradient descent method. And this last step is the stopping criteria. How you can find the stopping criteria? When we have to stop, the process will not move forward or backward anymore. So there are three stopping criteria are there. If any of the criteria is found or it matches, then we have to stop the process. So either the maximum number of iterations is reached, more than n number of times the movement is already happened, that is called as the maximum number of iterations has been reached, and the cost improvement is negligible over a fixed number of steps, as well as if the time limit exceeded or the time limit is reached. In any one of the condition is found or it is satisfied, in that case we have to stop the process. Before stopping criteria, what would be the solution we have? That would be the final result of this particular problem. I hope you might have understood how to analyze the problem. Now let me discuss one more question so that you will be clear. The second question says that you are designing an autonomous robot that must navigate through an uncertain environment where its action do not always result in predictable outcome. Now plan how you would implement a search algorithm to handle non-deterministic actions, ensuring that the robot can still reach its goal despite the unpredictability of its movement, and explain the steps you would take to handle multiple possible outcomes for each action. So two things we have to consider over here. First of all, we are designing one autonomous robot which can navigate the uncertain environment. Uncertain environment means in a dynamic environment, we are sending one robot to navigate the space. Here we have to plan or we have to implement a such algorithm to handle the non-deterministic action. Non-deterministic action means the action which cannot be predictable in advance by the agent. That we have to, how we can handle using what type of algorithm, as well as we have to find out the steps, what are the steps are required to handle multiple possible outcomes for a single action. Suppose the robot will move from one place to another place. While moving, it may move forward or it may skid or it may fall down. So anything can happen for a particular action. So this is the situation here for this particular question. We have to analyze and we have to find out the best possible steps. So this is the problem statement. Says you are designing an autonomous robot navigating a space where actions have uncertain outcomes. The robot must reach the goal state. These are fixed. The actions have uncertain means we are sending the robot to a dynamic environment. Now you take the example of the self-driving car. Whenever a self-driving car drives, it is not fixed that only one car will come in front of the car. It is not depending on the traffic it has to face, or it has to see different objects or obstacles around it. So that is called as the dynamic situation or the uncertain situations, and the robot must reach. Even if it is a dynamic situation, it has to reach the goal state. For example, moving north may fail or result in a slip to the side. This is the classic case of non-deterministic planning. So this is so these are the things you might have understood. What is autonomous robot and what are what the problem statement says here. Now here, what are the steps? Now we have to check as per the problem statement. We have to find the steps to implement a such algorithm to handle non-deterministic action. So to handle the non-deterministic action, we can apply different algorithms like the local search algorithm, like your hill climbing or simulated annealing. Even we can, in some situations, we can apply A-star algorithm also. So what are the steps? The first step is model the environment as a state space. Then because we have to consider the state space first, the environment as a state space, then choose a suitable search algorithm, then define the transitional model, construct a conditional plan which is called as the protocol or the policy, then handle the loops and failure and incorporate sensing for replanning if it is available. Then you find out what would be the stopping criteria so that we can stop the process. So these are the steps are required to implement the search algorithm to handle non-deterministic action. So as for the first step is model the environment as a state space. That means here each state means each movement of the robot or each movement of the agent is considered as a state. So each node in the search space is equal to a possible robot configuration. Now the robot can perform the action like move forward, or it can turn, or it can skid. So that is called as action, and each action can result in multiple possible outcomes. As per the problem statement it is given, I am not creating. In your problem it is given like each action can result multiple possible outcome. That means if it moves forward, so either it may 80% it may move forward, 10% may lift sleep, or 10% right sleep. It may happen. So these are the all possible outcomes for a single action. Now the second step is choose a suitable search algorithm. We have to apply or we have to choose the search algorithm depending upon the scenario. So as the scenario is robot's movement, so in that case we can, and that too for non-deterministic action or in dynamic environment, so we can go for AND or graph. That is the best suitable algorithm I can say. So use AND or graph search tree for non-deterministic planning, where OR node would be there and AND node would be there. So OR node where robot chooses an action, but AND node all possible outcomes must be handled. Like for example, if this is the final output, this final output can be configured or can be handled by 2 or 3 sections. So this is your OR and this is your and means this and this both should be handled, because if there is any or if both the conditions satisfied, then only one result will come. Or means any one out of two, any one you can handle. Suppose one action, this is one action, this is another action, okay, and there is no arc symbol is there, that means this is a OR node. OR node means any out of left and right, any one we have to apply or we have to choose. But AND node means if both the edges are connected with the help of AND, means both the conditions should be satisfied to find out the output. So that is the difference between AND or. Anyways, we have already discussed in my previous videos. So OR node and OR is the best possible suitable algorithm to handle the non-deterministic situation. Even here we have to plan a conditional plan policy that indicates the fallback actions. Now the third step is define the transitional model. So to represent the set of all possible outcomes for each action, we have to represent in the form of mathematical expression. Now this is one of the example I hope you can understand. This is for one action. Similarly, you can write the example for different actions. Now result, S result move. If S is an agent which moves, then what would be the result? So for S can be, it can move S1, the one action is S1, another action may be S2, another action may be S3. So S1, 0.8, S2, 0.1, S3, 0.1. So these are the three possible actions or outcomes are given for a particular action. And this is similar to a Markov decision process without reward. So pure planning we can say. So this is called as the defining the transitional model. That means defining all possible outcomes for a single action. Then the fourth step is construct a conditional plan or the construct a conditional policy. So at each step the robot doesn't just pick the action, it builds a plan tree. So for every action consider all the outcomes and plan how to proceed from each one. Ensure the plan covers all the branches until the goal node is reachable from every outcome. This is very easy to understand. So we have to, after doing all these things, we have to create one tree, and for every action consider all possible outcomes, and all the outcomes you represent in the form of tree and try to explore the tree covering all the branches to reach the goal node. Then the fifth step says that handle the loops and failures. So to handle loops and failures, you have to add, or during such tree exploration, we can add the visited state memory to prevent the infinite loop. That is why we used to use the either stack data structure or queue data structure to what are the nodes are already visited, to not to get confused, not to fall into the loop, and use the depth limited search if space is too large, and optimally design the cost and priorities to preferred paths. Then the sixth step is incorporate sensing for replanning if it is available. That means if the robot can observe its actual state after each action, then use a contingent planning. So replan the based on the real outcomes rather than handling all the possibilities ahead of time. And the last step is the stopping criteria. So when we have to stop, once the goal node is reached or the goal state is reached in all possible branches of the plan, or if the sensing is used, then stop when current state is equal to the goal state. This is the criteria actually. When the current state is considered as the goal state, I mean all the branches have been already explored, then we have to stop the process. So this is all about for this particular video. I hope you might have enjoyed and you might have understood. For the preparation of this particular lecture, I have referred this Soros Kosick for Artificial Intelligence book, where this local search algorithm non-deterministic actions are completely very briefly it is explained. You can refer this book, even it is available in the Amazon also. For your reference, I kept on the screen, it is visible to us. So till then, take care. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.